Dear student, I am Dr. MS and today we are going to discuss October-November 2019 paper 119702, and the total time for this paper is 1 hour and 15 minutes and multiple choice. So rest of the instructions you can see here. These are the some data constant values, and then after that you have the formulas here. And the first question is, for which quantity is the magnitude a reasonable estimate? So if you can see that the frequency of radio wave, they said 500 picohertz, mass of atom is this, the Young modulus is this one, wavelength of green light is this one. As we know that this question, even if you don't know the rest of the values, but very easier for you to know the visible spectrum, that is from 300, around 350 nanometer, 350 nanometer to 700 nanometer. So if we can see, the 7 is the red, 650 is the orange, and then similarly if you can go back here, this is the indigo. So around 532 nanometer is the wavelength of green light. So our correct answer is D. While the Young modulus of the metals are always in the order of gigapascal, so similarly the mass of atom is also 10 to the power some very small values, not micro, and similarly the pica, you can see that one. Second question is, the speed of wave in deep water depends on the wavelength and the acceleration of the free fall g. What is the possible equation for the v of the wave? Whenever you see this kind of question in exam, and if you are not familiar with that question, so the easier way for that one is check the right hand side unit and left hand side unit, and if the units are consistent, homogeneous, so that equation is correct. So if suppose I'm going to check the first one, that one is meter per second square into meter. So this gives me the meter square per second square root, and then we are going to get meter per second. So luckily my A answer is correct on that. Then they said here that the diagram shows the two vectors x and y drawn to the scale x and y, and if x equal y minus c, which diagram best represent the vector z in that one? So we can also write it as this, the one that x, if we can take to z to that side, so I'm going to use like this, z going to other side, so then that become y minus x. So y minus x, x I can change to this way here, so this is negative x here, this is y, so my first vector is y, I am going to add negative x with that by using head to tail rule, so this is my resultant vector, that is z here. So this is our answer for that, so the correct answer is A. Now the question number 4, they said a student intends to measure accurately the diameter of wire known to be approximately 1 millimeter and the internal diameter of the pipe known to be approximately 2 centimeter. Then they said, what are the most appropriate instrument for the student to use to measure these measurements? If you can convert 2 centimeter, that comes 2 centimeter, and the another one is millimeter. So for centimeter, it's better to use vernier caliper because the smaller length, and this is very small thickness, so we are going to use micrometer. So our correct answer is, for the wire we are using for the wire, and for the pipe, we are using, sorry, it's a misunderstanding here, for the pipe we are using caliper, and for the uh, wire we are using the micrometer. So why micrometer and caliper? So our answer is C for this here. Question number 5 is the about the uncertainties here. They said the power P dissipated in a resistor of resistor R is calculated using the expression that the formula is given to us. the percentage of V is 5 and the percentage of R is 2. And when we are going to find the percentage of P, so the percentage of P is the percentage of V times 2, because the power of V is 2. We always consider the power. And the percentage of R, so our answer is the percentage of V is 5 times 2%, plus the percentage of R is 2% here. So we get our answer is 12% total percentage uncertainty and D. So this is our answer. Now the next question is about the velocity time graph, and they said that what is the resultant force. So first we are going to find the acceleration, because the gradient of the graph is our acceleration. That one is V minus U over T, and the V value is 12 here. U value is it's around 3. Divide the time for this one is 15. So this means this is 9 over 15. And then you can use F equal ma. So our formula, because we are going to find the resultant force ma, so 2.5 times 9 over 15. So we can simplify it here. So 2.5 times 9, 2.5 times 9 divide 15. So the correct answer is 1.5. So our answer is C. Question number 7, they said that the which statement follows directly from Newton's first law. A body remain at constant velocity unless acted upon by the resultant force. Circular motion about the earth has a constant velocity. The direction change, that's not possible. A water drop leaving a spinning umbrella travel at constant velocity, again the direction change, no. The force acting on the object is equal to the change and rate of change of momentum. The force acting on the object is equal to the change in momentum. This is also not possible, so our answer is A. A resultant force causes an object to accelerate. What is equal to the resultant force? The resultant force, the acceleration of the object per unit mass, the change in kinetic energy, the change in momentum of the object per unit time, or the change in velocity of the object per unit time. The resultant force. Resultant force, if you can say, we can write it as the change in momentum over time. So we can say the change in momentum of the object per unit time. So our answer is C. Keep it in mind that the definition of force is the rate of change of momentum or change in momentum over time. Or you can say the Newton's second law is also the force is proportional to the rate of change of momentum. So our answer is C for this one. So